Good evening, class. This is pre-calculus practice test number 1, module 1, covering chapters 1 and 2. And here's chapter 1, functions, complex numbers, quadratic functions. This is the second part. We're going to continue with that. So we want to solve 2x squared plus 4x equals 5 using the quadratic formula. Remember, this is the standard form, so we bring everything to the same side. Then a is 2, b is 4, c is -5, and we put it into the formula x equals minus b plus minus a squared of b squared minus 4ac over 2. So we have 16 plus 40, 56 is the product of 4. And remember, you want to bring out a perfect square number if possible. It's the product of 4 and 14. 4 comes out as 2. Now, we factor the 2 out. This goes away. This changes to 2. And this is the answer. What about this one? It is in standard form. A is 7, B is 4, C is 3. So we write that. And we put that into the quadratic formula, x equals minus b plus minus a squared of b squared minus 4ac over 2a. And we try to evaluate. So $16, 3 times 7, 21 times 4, 81, so minus 84. 16 minus 84 is -68. Well, I want you to look at the number -68. It has a negative under the radical. You should always get rid of that and becomes a complex number. So that is changing to an I outside the radical. What about number 68? Number 68 is the product of 4 and 17. So 4 comes out as 2. The negative sign goes away and we write an I outside. By the way, sometimes they put the I in between because they don't want anybody to think I is under the radical. So we factor the 2 out, get -2 plus minus the square root of 17. And this is what we get. -2 plus minus the square root of 17i over 7. There are 2 answers. And again, they ask you can put it in a standard form, just in case. Standard form would be -2 over 7 plus minus the square root of 17 over 7i. So those are 2 answers. All right. We want to use the quadratic formula to solve this. Obviously, this is not quadratic in form, so the process is fairly simple. If you multiply both sides by LCD, this is a rational function, which is x squared, and of course, x can't be 0, will do the job. Why do we multiply by x squared? Because that is the LCD. So if you multiply by 2, you get 2x squared. By 4 over x, you get 4x, and these 2 will result in -1. 0 times x squared is 0. Now this is quadratic in form. A is 2, B is 4, C is -1. Plug it into the quadratic formula and evaluate. Minus b is -4 squared up, plus minus squared up b squared, 4 squared, minus 4a 2 times c, -1 over 2a, 2 times 2. And so we have 16 plus 8 is 24. Again, 24 happened to be the product of 4 and 6, and the 4 comes out as 2. So we can factor the common factor of 2. It's important before I continue. I want to make sure we understand. You can't cross them out. I've seen students doing that. You can't do that. You have to take a common factor, which happened to be 2 in this case. The 2 goes away. 4 changes to 2. This is the answer, or you can write it in this format. I want to make sure we understand what happens here. You can write this as negative 2 over 2 plus minus square root of 6 over 2. This is the answer. Either way is fine. And I'm writing it in this format because, again, I don't want anybody to be under the assumption we can cancel out the 2 from the top and the bottom. That is not how it works. We want to solve the absolute value equality, absolute value of 4x minus 75 equals 5. What is the process? Whether you have an absolute value equality or inequality, the very first step is to isolate the absolute value so that the equation is in this form, or inequality for that matter. Now, if c is less than 0, the equation has no solution. What do we mean by that? Let's say we have isolated, and this is minus 5. How could the absolute value be negative? Absolute value means distance from 0. Worst case scenario is 0. If it happened to be 0, you set this one equal to 0 and solve. If it's negative, there is no solution. If it's positive, if c is larger than 0, then we go to the following steps. We make up 2 fractions. We drop the absolute value, separate the absolute value into 2 equations, ax plus b equals c and ax plus b equals minus c, and solve and check. So we're going to drop the absolute value and make up 2 equations by writing plus minus 5. Please understand this means 2 equations. We're going to move the 7 and make it positive on the right side. We're going to divide both sides by 4. We get 7 minus 5 over 4, 7 plus 5 over 4. 7 minus 5 is negative 2. 7 minus 5 is positive 2, my apologies. 2 over 4 is positive 1/2. 7 plus 5 is 12. Divided by 4 is 3. So maybe we quickly write this is 2. This is 12. Those are the answers. And you really have to check both of them. I'm going to do one of them. I'm going to check this one. And checking takes place with the original equation only. So I'm going to write the absolute value of 4 times x, which is 1/2, minus 7. This is 7, everybody, that's 75. Is this equal to 5? That's what we are asking. 4 times 1/2 is 2. 2 minus 7 is negative 5. Absolute value of negative 5 is 5, and it checks, and we're done. Okay. You have to check number 3. It's actually very simple to see that. If you put 3, you get 12 minus 7 is 5. The absolute value of 5 is itself. Now, this is what I meant by isolation. Do not touch the absolute value until it's completely isolated. That means your first step is to get rid of the 1, meaning take it to the other side or subtract it from both sides, and absolute value of 2x minus 5 becomes 2. Now, because the right side, it's positive, you drop the absolute value, make it plus minus 2, which means you have made up 2 equations. You move the negative 5 and make it positive 5 on the right side. You divide everything by 2. So you get 5 minus 2, which is 3 over 2, and you get 5 plus 2, which is 7 over 2. Those are the answers. And you must check. Checking, again, takes place with the original equation. Let me erase my word. So I'm going to check the 3 halves here. 2 times 3 halves minus 5 inside the absolute value plus 1. And we're going to put a question mark at top of the equality sign. Is it equal to 3? We don't know. If it is, that's the solution. If it's not, we have to get rid of it. So these two cancel each other. We get 3 minus 5 is negative 2 plus 1. Absolute value of negative 2 is positive 2 plus 1. Is it equal to 3? It checks. We are done. So you have to check your work. All right. We want to solve the following inequality. Methodology. If the absolute value of x is less than a and a is positive, then you sandwich it between a and negative a. If a is less than 0, there is no solution. In other words, let's assume this was minus 7. How could the absolute value be less than a negative number? Worst case scenario is 0, so that's out. Now, because it's 7, you're going to sandwich it between negative and positive 7. To solve for this inequality, we are going to subtract 3 from all 3 sides. And then we're going to divide everything by 2. So x is between negative 5 and 2. This is the inequality solution, everybody. What is the interval notation? Parentheses minus 5 to 2. And I can't emphasize this enough. When it's open, when the endpoints are not included, everybody. You use parentheses. If we had equality, since we don't have equality parentheses, if we had equality, we would go with brackets. So that's pretty straightforward. On a number line, we are going to go from negative 5. So we're going to look at negative 5, and we're going to go to 2. You can put a whole or parentheses. Either way is fine. You could, let me just, you could also do this, everybody. You put a whole here. You put a whole here. And anything in between. That's one way to do it. Or we use parentheses, okay? And I'm going to, in fact, erase my work so you can distinguish between the two. Either way is fine. What about this one? Again, the very first step in whether you have an equality or inequality involving absolute value is to isolate, which means we are going to move the 10. In other words, subtract 10 from both sides. The absolute value of 5x plus 7 is less than or equal to negative 6. There is no solution because this is a negative value. All right, what about this one? 2 times the absolute value of 3x minus 1 plus 3 greater than or equal to 13. We are going to solve this by isolation first and foremost. However, let's remind everybody how this type of inequality works. If the absolute value of x is larger than a and a is positive, then x is less than minus a or x is larger than a. Union of events. This or statement is the union of events. However, if absolute value of x is larger than a and a is negative, the solution is all real numbers because the absolute value is larger than, let's make up a negative number. Negative 1, yes, of course. Because absolute value, worst case scenario is 0, therefore it's larger than any negative number. So having said that, the very first step is to move the 3, make it negative, divide both sides by 2, We get absolute value of 3x minus 1 larger than or equal to 5. Because number 5 is positive, we're going to go this route. That means we're going to drop the absolute value and say 3x minus 1 is less than or equal to negative 5, or 3x minus 1 is greater than or equal to positive 5. And we are going to solve two inequalities simultaneously. So we're going to add 1 to both sides. The first one becomes 3x less than or equal to negative 4. Or the second one becomes 3x larger than or equal to 6. We're going to divide everything by 3. X is less than or equal to negative 4/3, or x is larger than or equal to 2. This is the inequality solution. This one is negative infinity to negative 4/3. This one is 2 to infinity. And it's the union of events. So minus infinity to minus 4/3, union 2 to infinity. Because we have the equality minus 4/3 and 2, both of them, they go with brackets. So minus infinity minus 4/3, bracket, union, bracket 2 to infinity. Negative and positive infinity, those are concepts. They always use parentheses because they're not a specific number. So on a number line, there are two ways to do it. One way is to look at negative 4/3. Negative 4/3 means negative 1 and 1/3. So it's between negative 1 and 2. So roughly here, you put a solid point and everything to the left of it. 2 is here, not a hole, okay, solid point, and to the right of it. This is one way to do it. Or we do it with brackets in the following manner. Let me erase my work so you can see that. Or you can go with bracket and shaded to the left of negative 4/3 and bracket shaded to the right of number 2. All right, the absolute value of 5x plus 7 plus 10 larger than or equal to 4. We go with the methodology of isolation first, subtract them. So absolute value of 5x plus 7 greater than or equal to some negative number. It's negative 6, but any negative number indicates the answer must be all real numbers. Just think about it. Is the absolute value larger than negative 6? Yes, it's larger than any negative number. Solve and check. The square root of 2x plus 7 plus 7, 2x plus 1 plus 7 equals x. Anytime you have a root equation, this case is the square root, the first step is isolation. So you have to move the 7 and subtract it from x. Now that it's isolated, that means it's by itself. You have to raise it to an appropriate power because it's a square root. You take it to the power of 2. So raise both sides to the power of 2. Left side comes out as 2x plus 1. What about the right side? Recall a plus minus b quantity squared. A plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. Therefore, this is x squared. 2 times x times negative 7 is minus 14x plus 49. Now, we want to bring everything to the same side, and because x squared on the right side, we're going to move everything to the right in the following manner. This moves becomes minus 2x. This moves becomes minus 1. You combine them, you get x squared minus 16x plus 48. We want two numbers. The product is 48. The sum is negative 16. Those are negative 4 and negative 12. So that means x is either 4 or 12. Well, we have to check whenever we raise it to a power, especially if we raise it to a power of an even number. So we will check only with the original equation. So I'm going to put number 4 and see what happens. And then I'm going to put number 12 to see what happens. So 2 times 4, 8, and 1 is 9. So this is 9. As you know, the square root comes out as 3 plus 7. 10 equals 4. No. X equals 4 is out. Let's try number 12. 2 times 12, 24 plus 1 is 25. 25 comes out as 5. Is 5 plus 7 the same as 12? Yes, number 12 works, and that's a solution. So you check, and you check with the original equation only. X plus 2 quantity squared equals x minus 1 times x minus 6. How do we solve it? Well, there's really no way around it. We have to raise this to the power of 2, and we have to multiply this one. This is x squared plus 4x plus 4. This is foiling, gives you x squared. And then because it's x and x minus 1 and minus 6, they add up, they give us negative 7x. And the product of these two is positive 6. I'm assuming you have no problem with foiling because the reverse process factoring requires you to be very comfortable with that. We want to move things around. However, we notice we have x squared and x squared. Because they are identical, you don't have to move them. They cancel each other. If you move them to one side, you have to subtract. Then we move minus 7x. We make it plus 7x on the left. We move 4 and we make it minus 4 on the right. So 11x is 2. Divide by 11, x is 2 over 11. As always, it's really a good practice to check with the original equation. Part B, for x plus 1 to the power of 5 thirds is 32. Well, if you have an exponent, to undo the exponent, you can raise it to the power of the reciprocal of that exponent. The reciprocal of 5 thirds is 3/5. And remember, we are using the power rule, which says a to the power of m to the power of n is a to the power of m times n. That means the product of these two, which is simply 1. Okay, so you're raising both sides to the power of 3/5. The left side is 4x plus 1. The right side is 32 to the power of 3/5. And this is the same as a to the power of m over n. So you can write it in this fashion. Now, the fifth root also, this is just in case, this is also equal to the nth root of a to the power of m, reminding you of that. Everybody should know 32, the fifth root is 2. 2 cubed is 8. Subtract 1, you get 7 divided by 4. X equals 7/4, the final answer. All right, we want to solve this. There are two methods. We can raise 3x minus 4 to the power of 2, distribute 2, do the math, so on and so forth. However, because this is 3x minus 4, so is this one, you can go with the substitution. You can let 3x minus 4 be any variable of your choice except x. For example, let 3x minus 4 be represented by y. If so, this is 2 times y squared plus y minus 1. And now you know how to factor this. And factoring this is extremely simple because 2 is a prime number. So you have y and 2y. Minus 1, you have no choice but to go with 1 and you either go with 1 and negative 1 or negative 1 and 1. You just have to make sure the middle term works. Because however you go with those numbers, the first term 2y squared and the last term minus 1 work. Again, I want to show you that class. When you multiply these two, you get the first term 2y squared. When you multiply these two, you get the last term negative 1. You just are concerned with this. To do so, you multiply these two, you get 2y. You multiply these two, you get negative y. Then we must add up to y, and they do. Therefore, y is either negative 1 or 1/2. It's important to know we are not done. We are interested in solving for x. Therefore, 3x minus 4 is either negative 1 or 1/2. And that's what we are trying to solve for. Now, to solve it, we are going to move the negative 4, making it positive 4 on the other side. In other words, this is plus 4, resulting in 3x being 3. 4 is 8/2, resulting in 9/2. And so if I divide by 3, I get 1. If I divide by 3 here, 9/2. Just divide the numerator by 3, you get 3, so 3/2. Those are the answers. As always, you can go check with the original equation, class, and that's important to understand. You can always check with the original equation. X to the power of 2/3 is 2x to the power of 1/3 plus 3. How do we solve that? Notice, if you notice, if you raise this to the power of 2, you get x to the power of 2/3. Therefore, let x to the power of 1/3 be any variable except x, for example, m. And if that is the case, then this must be m squared equals to m plus 3. Since we want to solve it by factoring, we're going to move everything to the left. We want two numbers. The product is negative 3. The sum is negative 2. The numbers are negative 3 and positive 1. So m is either 3 or negative 1. Let me erase my word. So if m is 3 or negative 1, what is x? Notice, if I raise this to the power of 3, I get x equals m cubed. So x is m cubed. Just cube each one. I cube this one, and I get 27. I cube negative 1, and I get negative 1. And it's a good practice to go back to the original equation, only original equation, and check. Always a good practice to check. And checking takes place with the original equation only. All right, we want to solve r to the power of 4 minus 8r squared minus 15. And we're going to move the negative 15, make it positive on the left. You can factor it just the way it is. If you have a difficult time with that, you can let something represent r squared, for example, x, and do it that way. In any event, we want two numbers. The product is positive 15. The sum is -8, -3, and -5. So r squared is either 3 or 5. As I mentioned, we can go this route, everybody. And if we go with x, we get x minus 3 times x minus 5. And of course, then we have to change it to r squared. Okay. So if r squared is 3, r is plus minus square root of 3. If r squared is 5, r is plus minus square root of 5. So those are the 4 answers, everybody. Six b to the power of -2 minus 5b to the power of -1 plus 1 equal to 0. How do we solve it? I'm going to look at it with 2 different methods. Number one, we're going to go with the substitution. If we let b to the power of -1 be any variable, of course, except b, for example, x, what happens? Notice, if I raise this to the power of 2, I get b to the power of -2, which is x squared. So I have 6x squared minus 5x plus 1. Now, factoring is not too bad. First of all, this is 1, so we have no choice but to go with 1 and 1, both of them having the same sign. That means +1, +1, or -1, -1. Number 6 is the product of 2 and 3, or 1 and 6. And the reason we're going to go with this, and again, it's a trial and error. You can even try that one, because this is in an absolute value sense fairly small in a matter of comparing to 6 and 1. Therefore, we go with the middle one. So having said that, remember what we want. When we put 1 here, whether I put +1 or -1, I do get the last term also, but I need -5x, so I need to put negative. Take a look again. 2x times 3x, we know it's 6x squared. -1 times -1 is +1. We are interested in finding the middle term. So take a look. The product of these two is -3x. The product of these two is -2x. Do they add up to the middle term? This is how you check it. So what do we get? 2x minus 1 equal to 0, x is 1/2. 3x minus 1 equal to 0, x is 1/3. Now, what is the relationship between these two? It's important to understand that b to the power of -1 means 1 over b, which means the reciprocal of b. So if b to the power of -1 or 1 over b equals to x, then b is 1 over x. So the relationship between x and b is that the two numbers are reciprocals. Therefore, if x is 1/2, b is 2 over 1 or 2. If x is 1/3, b is 3 over 1 or 3. And again, you can obviously check it. And I highly recommend you do that. But we can also do the second method. Please understand this means, for example, if you were to write it out, this means 6 over b squared. So if you multiply both sides by b squared, and of course b can't be equal to 0, what do we get? If I multiply both sides by b squared cancels this one because it becomes b to the power of 0, which is equal to 1, we get 6. This one minus 5, b, this one plus b squared, 0 times b squared is 0. Now you need to factor this out. And again, remember, this is b squared, so your second degree term has a coefficient 1, so it's b and b. Then you want two numbers. The product is -6. The sum is -5. Those are -2 and -3. That's exactly what we got here. Now, again, I just wanted you to be exposed to both methodologies, and you choose the one that works best for you. Substitution method, multiplication both sides by b squared. It's important to make a point that b can't be 0, okay? B can't be 0. All right, a fitness club charges $20 as a monthly access fee and $2 per day of use. Express the monthly cost C in terms of daily usage. We're going to define a variable. Let X represent the number of days. We are going to look at Y equals mx plus b, everybody. Slope-intercept form. Of course, Y will be replaced by C, the cost function, C of X. M is the variable cost, $2 per day. B is the Y-intercept. Now we're going to call it the C-intercept, the fixed cost of $20. Therefore, C of X is 2X plus 20. So 2 represents the variable charge, which is the slope in essence, and the fixed cost. Just think about it. No matter what, they're going to charge us $20, even if we don't use it at all. So if Fitness Club charges $20 as a monthly access fee, just to access it, and then $2 per day. So what will the monthly cost be if it's used for 15 days? So it's very simple. You want the cost when X is 15. So C of 15 is 2 times 15 plus 20. That means 30 plus 20. It's going to cost $15, therefore. It makes perfect sense. I hope everybody's okay with that. If the length of a rectangular room is twice its width and its perimeter is 90 meters, find the dimension of the room. Well, we have a rectangle. We have the width, the smaller side. We have the length, the larger side, which is 2 times the width. So we're going to say W, L equals 2 times W. And the perimeter is 90. That means 2L plus 2W is 90. So L is 2 times W. P is 2L plus 2W equals 90. And I'm going to remind you that you can say P is 2 times L plus W. Okay, that's the same. So we are going to replace the L with 2W. So 2 times 2W makes it 4W. 4 and 2 makes it 6W. And now if we divide by 6, W becomes 15, and go back, you look at this one, the units. Every application problem, you must answer with the proper units. 15 meters, the length is 2 times that, 30 meters. Does it make sense? Here's how you check pretty fast. If you add them up, you get 45 times 2 is 90, and that's a proof we haven't made a mistake.